table, but if you don't remember the table, you can sketch out quickly the x-y axis. So it goes like this. If you do x-intercept, you don't know what x is, but you do know your y, and I'll show you in the graph here. When you do y-intercept, you don't know what y is, so you're gonna solve for it. But you know y has to, y coordinate will be 0. Here's y. X-intercept looks like this. If you don't know, I recommend you sketch out something like this. The table can be confusing, but if you do, if you sketch out an xy axis like this, and then sketch a line like going through here, you know that you don't know what x is, but you know your y coordinate is 0. Same with this one, it's a negative, but it will be automatically negative if you solve for it. And y-intercept, right there, if the line goes through y-axis, that means your x is 0 and your y, you don't know what it is. So these supposedly help you figure out, how to solve them. So I don't know if you're okay with that. Like, hey, x-intercept, your y is 0, because if you're always going to know it, y being 0. You don't know what x is, you're going to solve for it. And y-intercept, your x is 0 and your y is, you don't know what it is, right there. So if you can draw this every time, you can never miss it. So let's do it. So I know it's vertex. Okay, I went and explained how to get the x and the y-intercept. Okay, let's do it in order. Vertex. If you do vertex for a form that looks like A, B, and C, there's a particular way to do it. But if you do a vertex for a way that has a x and y-intercept given to you, there's an easier way to do it. So I'll show you that. So they're different. But you can make them the same by multiplying everything together, but you waste time doing it. Imagine that, okay? Because you got to distribute the two and FOIL it and all that. So you spend a little more time, but it's still doable. You don't remember, you can still always do it. Well, okay, how? If you have them in X, a trinomial like this with A, B, and C being a parent, then you would do a vertex this way. Oh, that's cool. Right. The vertex will be relating to X coordinate. So here, let me write vertex here. To do the vertex with A, B, and C, you do the X coordinate being negative B over 2A. What that is that if the graph looks like this, the negative B over 2A, it gives you the X coordinate of the highest point or the lowest point. It can be concave up or concave down. So the X coordinate with this formula will give you that particular value for the highest or the lowest point. So I recommend you do vertex if you have A, B, and C, using this every single time, just for the X coordinate. But the Y, you plug it back in. So let's do it. So here we go. So you're using this as the X to get you X coordinate. So it will be a negative. The B, negative for the whole fraction. B will be 4. 2 times A. A is negative 1. I hope you're okay. That's being a negative 1. And then just compute. You get negative become positive. So it's really 4 divided by 2, which is 2. So X equals 2. So if you want to write the V coordinate, like vertex, you can do V 2 comma something. So the vertex is V 2 comma something. And then get the Y, plug the X back into the original. All of them in there. So you plug it back in, it'll be negative 2 squared plus 4 times 2 plus 7. Whatever this is, so it'll be negative 4 plus 8 plus 7. What is that? It's a 4 plus 7. 11. So 11. So that means 2 comma 11. We can always check back on that, but I'm sure everything's right. Negative B 4 over 2 times negative 1, yeah. So it's going to be a 2 to plug back in. 4, 8, yeah. All right, looks good. So it looks like it's 2 comma 11. So here's your vertex. Okay, now x-intercept. I'll go up here, okay? X-intercept, based on the graph and the table, you can pick either. I always go here. I always think that, but I know it well. It's just like the opposite thing. So I do a table. I do the table more often than the graphing, but if I ever forget, I visualize it this way. Okay, here we go. X-intercept for 46. x-intercept is when your y is 0, as you can see here. So you plug in the y being 0, and then solve for x. So it's negative 2 plus 4x plus 7. So you're going to solve for x. I recommend that you factor, but you never factor with the negative 1 in front of the x squared. So multiply everything by negative 1, both sides. Negative 1 times 0 is 0. And then change all the signs here. It'll be a x squared minus 4x minus 7. And then factor, if possible. If not, we do quadratic. But we always attempt to do it by hand first. So let's see. Yeah, it's not possible. Yeah, dang it. Because the only combination you have is 7 and 1. You will never get a 4 out of it. So, but you can show the word like that. Just leave it like that. But then go back to quadratic. We're going to do quadratic formula. But when you do quadratic formula, you cannot, you don't want to use this form. You got to use the negative as is. So what I mean is that you're going to do A, B, and C as is right here. So you didn't know that, by the way. Is that okay? You didn't know that you cannot do it by hand. So therefore, it's okay. So go back to the quadratic formula. Here we go. The x, we're still doing x-intercept. So none of these work. So I'll scratch that. So I'm going to do the quadratic formula. Here we go. Negative b, negative the b of the original, okay? With the negative being 1 being a, negative 1 being a. But right now it's negative b, which is negative 4, plus or minus b squared, which is going to be 4 squared, minus 4 times a is negative 1 times c, which is 7, all over 2 times a, 2 times negative 1. Okay, clean it up. It'd be negative 4 plus or minus a root. So it's a 16. 16, I'll write up here so I don't have to write too many roots. 16 minus, it's a plus this time, good. Negative 4 times negative 1 is a plus 4 times 7, 28. So let's see, what is that? 34? I think, double check. Yeah. That's even nicer because you cannot simplify that. Because in the root, the only factor you can come up with 34 is 2 times 17. Let me double check. Yeah. So both of them are prime numbers. Therefore, this is your answer. I'll double check that with like this WooSram app, but I'm sure this is fine. Anyway, this is your answer for your x-intercept. You can label that x-int again if you need to. Yeah, you can't simplify that further. So leave it like that. There's 2 answers, you know, the plus and minus one. Right, for y-intercept, I'll do it over here. Y-intercept, it's easy. You solve for y when your x is 0. See, when your x is 0, just solve for y. Just plug in. So y-intercept, just plug in your x. Like you think opposite, you know, like put the x being 0 and all that. So here we go. I'll plug in the x being 0. 4 times 0 plus 7. So all of this is gone. So you just left with y equals 7. So your y-intercept is 7. Oh, if you were to write a coordinate form, which is not fun for this, you can still do it. So it looks something like this. Y being 0, comma, x-intercept, okay, we're still doing. You can write this whole thing in, you can write the whole thing in the x coordinate, sorry. The x, comma, y looks like this if you were to write it. I don't think you need to for this one because it's just a rational function. It's like this, comma 0. So this is your x-intercept. If you were to write the coordinate form, x comma y form, for the y-intercept, you can write the coordinate form. You can, if you want to do that, it will be 0 comma 7. There. Okay, that's done. You okay with that, Russell? Mm-hmm. For 47, it's not an A, B, and C form. You can make them and do the whole thing the same. It does not necessarily mean that you're going to get the x-intercept being this messy. It could be a nice, you know, if you factor it, if it works, then it'll be a nice, you know, 2 answers. X equals something, x equals something else. So, okay, anyway, I cannot. Okay, now, it's not A and B, you can still make them, but you don't have to. Here's the way you want to do it. If you had it as a, let me show you in the graph. You don't need to graph it, but I'll show it to you here because it's easy to understand. It remember this is the x-intercept is at -3 and -9, but you're gonna write it in order: -9, -3. You see it? Like if you set them equal to 0, you know, your x-intercept on the x-axis, well, let's say the x and y-axis right here. This is your y-axis, x-axis here. It will go through these 2 points, but how? It's a positive, so it's going to concave up like this. Now you don't need to do any of this. You just watch me solve it, and you can memorize that. So the graph will look something like this. It might go lower, the butt end of it. It might go lower or higher, or like up here or whatever. But it will go positive like that. That means all you need to do is basically find the average. You know, we want this coordinate. You know, like the. Oh, wait, sorry. What am I doing? The x. Sorry. I thought they wanted. Oh yeah, you need to do it for the vertex. No wonder why I was doing this. Yes, so we're doing the vertex in that order. So we got to do the vertex. The vertex is like this. It's just a sketch. It will go through this point. You know that means you could just find the halfway between them, between -3 and 9. See that? So you get that the x coordinate. I'll even show you the math here. We don't know the y. We'll solve for the y, but the x coordinate, the math is simple. It's -9, or it doesn't matter which one first, plus -3 divided by 2. Like you average it, and then you solve for y. So let's see what that is first. So this is the vertex. So I'll put V for vertex here. V parenthesis. In higher math, they notate it that way. V parenthesis x comma y. So what is that? -12 divided by 2, -7. Yeah, -12 divided by 2, -7. Then we'll plug that -7 back into the original to get your y. If it's written as a factors form, this is how I would do it. So plug -7 back in. So here we go. Y equals 2 times -7 plus 3 times -7 plus 9. Yeah, just be neat with your math here. So y equals 2 times -4 times 2. So y equals to -16. Double check here. I plugged in -7 because I got it easily by doing this. It's between, -7 is between -9 and -3. Wait, is that true? No, I got it wrong. It's -4. -9 plus -3 is -12. -12 divided by 2 is -6. Sorry, it's not -7, it's -6. I'm glad I looked back. You okay? -9 plus -3 is -12 divided by 2, -6. That means these are wrong. So let's do the y again. So y, y equals 2 times -6 plus 3 times -6 plus 9. So y equals 2 times -3 times +3. So that'll be, it's fine to have a fraction, okay? So this one is going to be, what is that? -18. -3 times -3, -9 times 2, -18. So it's way down there. So the graph is way down there. So I can check this quickly if you want. I'll do it quickly. 18. So that looks good. So here, how do I check that? Just quickly, okay, in the graphing calculator. If I graph it, be 2 parentheses. Oops. Sorry. 2, 3, and 9. Okay. So here, 2 parentheses. X plus 3. No, x plus 3, and then x plus 9. Okay, graph. So here, take a look. So I zoom in. Zoom in. Yep, it looks just right. You can see, here's the way you do it. This is pretty fancy. The app, you just kind of touch it, like the lowest point. That's your vertex right there. There it is, -6, -18. You see it? There it is. So the math you do is, I recommend you do exactly the way I did it here. Average the x-intercepts, plug, once you get the x coordinate, plug it back in. So this will be -18 here. Anyway, all right, I hope you're okay with that. Now let's do this one. X-intercept and y-intercept. Again, for x-intercepts, let's do x-intercept first. Make your y equal to 0. This is your y. F of x is your y. Make your y equal to 0 and solve for it. I'll factor it right now. No GCF, nothing you can pull out. All right, let's try it. 3x and x for the first. The last is like 4 and 2. I'll do 4 here and 2 here. Nope. If I do 4 there, I'll get 12. It's too big, too far from 12 already. I'm about to get more than 12 or less than 12. So I'm going to do 4 and 2 here. Let's see. The outer, I get 6. Inner, it's 4. I won't get 12. I can never get 12. So it's at most 10, at least 2. So, okay, fine. I'll do an 8 here and a 1 here. All right, let's see. Not nice. Your teacher making them not nice numbers. You're going to have to do quadratic formula. Nice. Yeah. So you attempt it, right? It doesn't work. Then your other way is to do quadratic formula. Don't do completing the square or anything. I'll do it one more time here. 2 and 8, 2 and 4, 6. Yeah, 6 and 4 will be 10. I cannot get 12. Yeah, can't do it. 1 and 8. Nope. Yeah. 3. Yep. 11 at most, not 12. Yep. No other way. If you do 8 here, it's too far. Like 24. All right. So you kind of like test it out. It doesn't work. I scratch that. All right. Let's do the quadratic formula for the x-intercept. All right. X equals -b, which is -12. I'll parenthesize that to show the substitution. And then 12 squared. B squared minus 4 times A. A is 3. A, B, and C here. 4 times A times C, which is 8. All over 2 times A, 2 times 3. Okay, and then continue. -12. What's the minus? Sorry, minus there. 144 minus, what is that? 12 times 8. All right, I'll hit in the whole thing. I do know what that is, by the way. But I'm going to make sure. 96. Yeah. There's 96. I'm doing this here. Then 144 minus 96. 48. Okay. Yeah, your teacher doesn't have to make it all messy here, but it's fine. Over 6. But then I see the reason behind that, because you were simplifying roots, also, right? You were for review.
Yeah.
All right, then let's see. Root of 48. 48. I'll just prime factorize it. Or you can do 4 times. 4 is a prime. 4 is a perfect square. You can keep it. 4 can go into 48 12 times. Oh, I see it now. And then so check this out. It depends how you do it, how you gather this. This is 4 times 3. It's really 16 times 3. But you wouldn't know that, right? 16 times 3 is 48. Many students wouldn't know. I overlooked it. I remember it, but I don't. I do remember it now, not before. So pretend you didn't know this, but I already know it's really 16 times 3. 16 times 3, but I'll show you another way, okay? 16 times 3,
Oh,
so
yeah.
they're inside the root. Therefore, it's really a 4 root 3 if you were to simplify it. So that means it's like this, but I'll show you quickly, okay? But let me write it here. So 4 root 3 all over 6, but we're not done here. But okay, let's say you don't know how to simplify root 48. You do it like half everything. Here we go. 2 times 24. Circle the prime number. 2 is your prime. 60, 24, double check. Yes, 2 times 24. Break that up again. 2 times 12. Continue. 2 times 6. Continue. 2 times 3. Okay, so circle all your primes and then gather them back. But the way you gather them is that every pair comes outside once. Every pair that you see, so root of 48 is the same thing as 2. Every pair comes outside once. Another 2, and then the 3 is what you have left. So you got to keep in the root. That's why it's 4 times them together, root 3. Same answer. Now this can be done different again, but if you don't know, you would break it all up and then gather every pair come outside the root, not the house, but the house can be a division symbol. But anyway, outside the root once, and then keep. If you have more, just keep bringing it out and then multiply them. But if you don't have anything left you can bring out as a pair, you keep it inside like the 3. Hope you're okay with that. Okay, continue. I hope you're okay. Now this here, you're not quite done. The quickest way to simplify is these right here is that 2 can divide into all of it. So just go ahead and mentally cross cancel them. For example, 2 can go in negative 12 6 times. 2 can go into plus stay plus or plus and minus. Sorry, plus and minus. 2 can go into 4 2 times, but keep the root 3 there. Oops, I can't erase that. But I think you can see it. But let me write it over here. So, or I'll squeeze it in right here. So that final answer is here. It's going to be 2 can go into negative 12, negative 6 times. 2 can go into 4 plus or minus here. 2 times root 3. 2 can go into 6 3 times. Here it is, final answer. 6 plus or minus 2 root 3 all over 3. Hope you're okay. That is just the x-intercept. The y-intercept, this is x-intercept. Again, if the answer is this weird expand rational, with the root thing, I would leave it. I don't want to put it back into the x comma y. So forget it. Is that okay? So here's your x. Yeah, just leave it like that. And your y-intercept. So y-intercept for number 48, plug your x with 0. Substitute x with 0. So it's 3 times 0 squared plus 12 times 0 plus 8. So y equals to 8 because everything else is canceled out. There it is. X and y-intercept. But label this one as y-intercept, int. And this one is x-int. I know it can stand for integer, but they always use it int for intercepts anyway. Okay. I hope you're okay with that. You got the vertex, x and y intercept. Okay. Now, 49, what do you think? Should we do 4951? They want you to write the equation in the vertex form, then state the vertex. Yeah, I think this is something you may have to do because this is completing the square. So you need to, they force you to do it for solving the equation, but you only get one. You can do one time, but now they really want. Yeah, you can't get away with it. It seems like All right, let's do it. Is that okay? Let's do maybe one, at least one. So to do a vertex form, basically it's going to be HK. So the way it looks is like this. Let me write it out. So y or f of x. If you wonder what it looks like, it looks something like this. It's exactly like this with the variable even. They use a also. Here we go. It's a times x minus h squared plus k. So I think you might recognize this. So here it is. You're going to make them look like this, or f of x for y. So to do that, they're being generous here. They gave you the a being 1. That's good. If it's not, it's very bad. It's pre-cal stuff. So they give you it being 1. Therefore, I think I mentioned this a little bit in solving. That means it's good to go. You can just do it nicely. Now, I'm not going to add both sides by 7. Do you remember? I think you might have done that. Like, let's don't do that. Let's do pre-cal. Watch me do pre-cal. Like you guys didn't, I think you were taught to add both sides be y plus 7. It's chunky. You don't want to do that. Don't do any of that. Watch. You already saw me do this like in the solving bit once. It will look just like it. Watch. You want to do this because pre-cal. Now I can't guarantee the pre-cal teacher will teach it exactly like the textbook, but many of them do. So let's do it. The teacher, pre-cal teacher may still have you add it over. I doubt it, but there's some still can do that. They can do whatever they want. So here we go. Complete the square. Take the 12 divided by 2. Your A, B, C, B, and C. You don't need the C. You don't need the A, just the B. So take the B, whatever in front of the X, divided by 2 and square it. Simplify it inside the parenthesis. Keep it because you're going to need the number. So it's 6 squared. If it's a fraction, keep it as a fraction, but I don't think you have to worry about that. It seems to be generous here. 36. Okay, watch me do this. I think you've seen this. The 36 you would have been adding to both sides by now, algebra 2-way. So here we go. Don't do that because you didn't do it for the plus 7. You don't add 7 over. So keep everything on the other side. Here, it looks like this. So you come up with this number. It's a special number, which is completing the square process to get this special number. And this is where you want to place it. You want to place it immediately behind the x term. I think you might remember that. You want to add it and you want to subtract it, but you can subtract it behind this number if you want, but I'll add it and subtract it. So I think it's kind of cleaner looking. Then I'll bring the minus 7 back. So you basically insert this number, adding, subtracting it right behind here. Mm-hmm. Is that okay? I'll do another one. You'll see it. So when you do that, what happens is that it will turn into this very, very, very fast. So if you continue, the first 3, the plus 36 will be part of it. It's factorable into exact same. I might not have written this way, but I show it to you with the word same here. So if you do it, it will look like this. And the last 2 can be combined and placed in the back here. That is your K. If it's minus, it's minus. This one is a plus, it's a plus. So what is this? I'll do the last one first. 43. So it's a minus 43. Yeah. Now, the factoring of this one is easy. It's x. Guess what? It's this number. If it's plus, the one before you square it. If it's plus, if it's negative, it's negative, okay? But this needs to be a negative b. But it's a positive b. Everything's positive. So it's plus 6. You're pretty much done. So it's going to be x plus 6 squared minus 43. Done. 43. So I recommend you do exactly this way. It's pre-cal. So let me do this 50 quickly, and I'll let you do, I'll do 51 because that's a negative. But 50 will be the same. Okay. Is that okay? So I'll do this one. Take a negative b, divided by 2, and square it. But keep it, everything inside the parentheses neatly. So it'd be negative 4 squared. Okay, so, and then if you continue, it will be 16. So that's a special number, but the negative 4 will be used, right? So I'll rewrite the original looking like this. I'll add and subtract 16 right behind here, behind the 8x, and indent that minus 1 over. So here we go. 8x plus 16 minus 16 minus 1. So I'm putting, don't forget to keep the 1 that you got back here. Yeah, the 16 is a special number. Add and subtract it. Okay, rewriting it. So I know it's the same. I'm just going to write it squared. Is that okay? So it'll be same here. It'll be x minus 4 is this thing right here, squared. You can factor it. You can do it by the way that you know how to do it, the first 3. It would be x minus 4. So I'll write x minus 4 squared. So that's what you would get for the first 3. And then the last is minus 17. You're done. See that? So here's your final. What about A? A is 1. It's always the original coefficient of the x squared, 1. So you don't have to write anything. A is 1. Like the A. Okay. Yeah. There it is. So try 50, okay? I think you'll be okay. All right. What else? Graph or word problem here?
I think the graphs first.
Okay. Which ones? Maybe these ones, yeah?
That one, yeah.
I don't remember working this one with you. These here.
And this was from quite a while ago, so.
Oh, maybe, right? Maybe, yeah, I've done, yeah. But let's, again, review because, yeah, right. Yeah, okay, it's coming back. All right, let's do this again. I think I've done it, but, all right, let's review. This is a bounce. This is the intercept, okay? So based on this, I can tell that it's going to look something like this. Y or f of x? I'll do f of x. So you don't know what a is, so we'll solve for it. So I'll write as a. Now for the bounce, it's squared. For the intercept, it's just to the first power. Is that okay? Like that. Now, I think you might recall the third power. It's positive. This is going to be a third power graph because of the hump. There's two humps like that. So the parent function looks like this. But this is going to be third power. But if you don't remember fully, it's fine. Just gather the information. This is the squared. This is the first power. Automatically, it'll be a third power. But don't worry. So anyway, why I'm mentioning this is because a will be negative because it's decreasing. It's going down. But when you solve for a, it will be automatically negative. So watch. Let's continue. This would be a negative 2 here. But remember, you do the opposite there. So it's x plus 2. This is a positive 2. Okay, fine. But wait, the negative 2 has to be the one that bounced. So that's why it's under the square one. Is that okay? Right there? The one that's going through, it's just going to be the first power or odd power. But don't worry about the odd. It's just always first power. How about that? So it's a opposite. This one is a 2. Therefore, it's going to be x minus 2. Exactly like that. Almost done. The only other thing you need is to solve for a. So let me make that a y now. So it's a y. You need to be sure of the point that any other point that you can find other than the x-intercepts, the one that we used. So for example, the point that I think I might have used with you is this one. I don't know that. I would not have used that because that's like a halfway or something. It's crooked even. The number, the x comma y that I think is recognizable is right there. This right here. Which is x being 0, comma y being 3, I think. No, 3, sorry. I thought that was the x at 2. It's not 3. X being 0, y being 1, 2, 3, 4, 5, 6, 7, 8. Y being 8. So it's x comma y. And it get pixelated. X comma y. Is that okay? So your x is 0, your y is 8. So I mean, it's nice that one of them is 0, but it just happens to be this one, this graph. So, okay. So it's nice to use it because you can get it really fast. So here we go. I'm going to solve for a. Your y is 8. So substitute y with 8. And then a you're trying to solve for. X being 0, all of them. And then, just clean up and solve for a. So a 0 plus 2 squared, that's going to be times 4 times negative 2. And then 8 stay 8 on this side. Then you're left with a times negative 8. And then divide both sides by negative 8. So a is negative 1. And if you remember, I was saying that it's going to be negative. There it is, negative 1, automatically. So you don't have to worry. So we've pretty much done. Reuse this function. You can now call it f of x instead of y if you want. And then negative 1. You don't have to write the 1, but at least you need to write the negative. But I'll write the negative 1, the whole thing. A being negative 1. And then everything as is. So final answer. Here it is. I hope you're okay with that. Write an equation of each graph. Yep. Okay, just quickly, maybe we don't need to do this entirely, but same idea. Watch, let me set it up. So, or y, I'll do y here for the 75. It's a fourth power, but again, you don't need to worry about it. I think the best way, if it's curvy, don't worry about what is. Oh, I forgot to mention. I believe your teacher may accept this form. You might have to multiply all this out. I don't think you should. Okay, I don't think your teacher will be that mean because you expend a lot of time. You already use a lot of concept to gather to get the function looking like the way it is right now. Remember, the other ones are also factored form. You know, like this one over here. That's why I think you should be fine. Like right here, see, it's factored right there, number 47. So I think you should be fine just leaving it as is because that's a lot of time for you to actually multiply it all out. It's a third power. So I think you should be fine. I'm like 99% sure you should be fine. This one, same way. I would recommend you leave it as factored form. So 75, again, you don't know what A is, but you solve for it. But let's do it from left to right. Do this one, and that one. From left to right, the first one is -5, so it'll be x plus 5, opposite. -5 here. Double check, 1, 2, 3, 4, 5. Yeah. And then this one is 0. The 0, 1, it's always x, like x minus x plus 0. But since it's bounced, you square it. I hope you're okay. You can make a note here, or you can use the arrow. The last one, we'll go here, opposite again. This one is, what is that? 4. It's positive 4. Therefore, it's x minus 4. There it is. Now, you need to solve for A. I don't remember this one. I think we were kind of like contemplating or whatever, looking for it. Yeah, this one is the one that I remember now. Nothing is certain. So I might have used this one. It doesn't matter. You're going to get some weird fraction out of this. I think this one has some weird fraction for A. And it'll automatically be negative. I know it's negative because it's like facing down or concave down. So do you think you can do this one okay? But you got to pick a point. I don't know which one you want because I don't think we actually agree on any, but I don't know. I might have actually picked this one as x comma y to plug it back in, you know, up here, x, y.
Yeah.
This, it might have been -1 comma 2. -1 comma 2 x, y. I don't know that. It might have been wrong. I might have picked another one down here. I don't think you should pick any of down here because you that's like pixelated. It's bad. None of them looks right. So, but this one is the closest thing. No, when you do pick, or wait, no, don't do this one. It looks like it's crooked. But anyway, if you point the arrow to it and you went through the solving, your teacher will have to accept it. Is that okay? Yeah. If the test is also pixelated, it's like kind of crooked and bad. It's computerized. I can tell it's like printed kind of bad. So you think you're okay solving for it, or it's weird fraction? I remember. So you can read something as is, but A being okay. What do you think about 76? It's up to you, okay? Or do you want to do something else? And 71.
I think 66 and 7 just because they're doubles.
Yeah, let's do this. Now, there's a concept you do it really fast, so you don't have to do the transformation table. I think we're doing it because all that's going on. Transformation table. So let me quickly how you can study. You have to know your parent function looking like this. The parent function looks like that, and it's facing this way, like that. This time you do need to know your A being negative or positive. So it's different than the curvy ones. Know the difference that these two are polynomials. It's kind of different thing. A, you get them out of these here. With the x comma y. But A that you're about to get is really the one thing. I recommend. I'll show you. So the fastest way has to do with this box thing. I don't know if I showed you this. This box, if you can actually look at the graph and establish it being one square box is this one. How would it look being 2? I don't know if I've shown you this. The 2 will look something like this from the HK or the origin. Like it depends. If it's shifted, then it's not at the origin anymore. So watch. What if it were 2? How would it look? So it's possible that I think you can get 2 or 3, not a 1. I don't think on the test. Let's see. How do you actually know if it's going to be a 2? I'll show it to you. The way you stack them from the HK or 0, 0 in this case, you stack 2 up this way and overlap 1 and 2 this way. Stack 2 this way and overlap this being 1 and 2 this way. You see it? So it's 2 boxes, but stack overlapping each other. But then how do you connect them? You connect them on the edge here, like this. This is being positive, okay? This is being positive. 2. There it is. And if you ever need to actually write a table out of this, you can. You get 4 points, actually 5. Including the HK. The HK is easy to find because it's like right here. So you get 5 points if your teacher ever need to write x comma y or a table. You can do that. So whatever this is, like pretend this is at 0, then it's 0 0. 2 comma 1, 2 and 1 here, and 2 comma 1 is also 1 comma 2. See that? And then you can do the same thing on the bottom here with the negative and all that. Is that okay? I don't think you need to do that either. Okay, I don't think you need to do the table. Now, how do you do it for this one? This one, your numerator is 1 automatically right there. See that? Mm-hmm. Yeah. But I remember there was a graph that you had 2 or 3, either you or my other student also doing the same thing here. They had it like, does not look like this, but it's stacked up to be a 3 even, I think is a 3. So a 3 would look like this, stacked overlapping each other. But it will go through this corner though. So it's going to have a little bigger gap. Imagine?
Yeah.
Yeah, so okay, I hope you use this. This is like a college way. Student can sketch this in college really, really fast this way, the way I've showed you here. So yeah, none of those wasting transformation table. So one, but notice the only difference is that it's facing the other way, it's negative 1. So if I write the function right now, it's going to look like this. Now let me write the generic one. I guess you can call it A, x minus h plus k. The A is the way that I showed you, okay? So here it is like this function. Now, parents think this way, see how it's like it's supposed to go like this, like this. The A is negative. So we go final function for this graph. It's gonna be negative 1. I know it's negative. You could put it in the front of the fraction bar. Put it on top. It's fine. Your teacher will be perfectly fine. The h is always the opposite here. This is your hk. Let me see what is that. H is negative, comma, the k being exactly the same sign, 4. Therefore, it's going to be plus 3 opposite. Same here, plus 4. Same sign. There it is. This is your function of this graph. Plus 3, okay. Negative 1 over x plus 3. Opposite the hk here. That's your huk. Don't forget, I'm going off this. But the a is, we're doing it different. Do it the box thing, if you can identify it. But it's 1, therefore it's done. But it's negative because it's faced the other way, it's flipped. Is that okay? You think yeah. Okay? Okay, 77. Let's do from left right. Now, it's going to be a piecewise, so it's expected to look like this, right? And like the chin out. I'll go over that line there. And to do it, just do your very best to see if you can go through the y-axis. Why? Because they're all linear. All this here is be y and x plus b form. All of them. So expect this is what you're doing, all of them. All right, here we go. Now, based on what I can see, it looks like rise 1, run 2, rise 1, 2, like that. So then I'm going to do here. It will go through this point. That means that B. Don't forget your B is your y-intercept. Oh, y-intercept. Just the y value where it cuts through the y-axis. The y-axis. So if you look at it, it's based on the rise on B going through 4. So we have to do the ms. I hope you remember the picture choice form. Going down up is the numerator. The m. Let me see. I'll write it. The m for this line is negative. It's negative because it's going down. How about that? I think you might remember me mentioning this. Is the fastest way. So you have to think about, hey, left, right being negative, whatever. If you look at it from left, right, it's going down. It's negative slope, so it's negative immediately. The only thing you need to come up with the fraction, the rise and the run. The rise is always like going up or down, so it's 1. Up or down is 1. The run is always left to right, like side to side, so it's 2. So it's 1/2 for the m. So therefore, it's negative 1/2 x. Or you can do negative x over 2 if you want, but I'll leave it exactly like this, negative 1/2 x, done. But you need to write the restriction. Remember, the restriction is easy. You look at where the line exists. It's from x being 2 on negatively. X, yeah, like at negative 2 on for this here. Yeah, your restriction is x, basically your domain, your x values only, okay? So the restriction for this one will be, let me see, I can erase it. Oh, nice. I want to put a comma right behind it. So the restriction for this one will be x less than negative 2, including, because it looks to me like this is the open one and this better be closed one. It's always like that for piecewise. If one is open, the one on top or below will be closed. So it's closed. So it's bar. Is that okay? Oops. So let me erase this a little bit. I think you remember it. So what I'm saying is this right here is closed. So it's negative 2, including negative 2. Okay, now we're going to do this one. Easy. The b is 0. Your b is 0. You're going through the x-axis, the origin. The b equals 0. So therefore, it's plus 0 for the b. You don't have to write that. But the rise and run is positive. First of all, the m of this slope is positive 1, because rise 1, run 1. Rise 1, run 1. Okay? And if you scan it from left to right, it's increasing. It's positive. Yeah, I think from here on, if you ever need to know the slope, like the m value of a line, that's straight line, okay, it's slanted or whatever, but they're still straight. It's positive or negative can be looked at easily by looking at, is it going down, going up from left to right. So it's positive. So it's basically 1x, positive 1x, done. I hope you're okay with that. It's 45 degrees. Rise 1, run 1, rise 1, run 1. It's positive. But then you have to write the restriction. It is between negative 2, not including, so you don't do a bar here. In between, you write it this way. I think you remember, like the less than, to a positive 3. It looks like a 3 right here. So it's like between here. So it's a 3, but it's inclusive of 3 because of the closest dot right there. So it's barred here. Okay, done. How's that for you? Is that okay for this one?
Yeah.
I don't know what is that. Oh, that's not a 1/2. Okay, it's the negative 2, the x coordinate. Okay, now the last one here. Now this one I think I remember is a little tougher. So to me it's rise 3, run 1, but it's positive. The m of this one is exactly positive 3 over 1. Rise 1, run 1. Any rise or run, it's always the numerator. Rise 1, run. So based on that, I'm going to go and do it downward, opposite direction, down, run this way 1 and run 3. Oh, I have to erase some of this now. Since you got that, I'm going to erase this to get my beneath for the last one. So let's do it again here. So I look based on this, like over 3, over 1, and then run down 3, 1, down 3, 1, down 3. Here it is. This is the x-intercept. Double check. Yep. I know we extend it further than the line, but we need to pretend that it continues all the way. You know what I mean?
Yeah.
Oh, why does it look kind of weird? Let me see. The line goes like this, doing this, through this. Oh, I'm wrong. That's not true. It's way down here. See, that's why if I were to select that, it would be crooked. So I got it wrong. The drawing is right, but watch. Continue with me here. So I did the step thing, you know, like backwards here. That's not the intercept. Okay, so I went over here and down 3. Here it is. This is the intercept. See it? It will go through there and continue
Yeah.
here and here and here like that. So that is the y-intercept. So the b is this one here. So b equals negative. Let me see. Let me count it. 1, 2, 3, 4, 5. So it looks to me as negative 5. So b is negative 5. So I think I can put them all together now. I think it's negative 5. Double check. Is it negative 5? Yeah, it looks like a negative 5. Yeah. Okay. So it's a minus 5 for b. I put it down here a little bit. And the x is, the m is 3. So it's 3m, positive 3m. I mean, m is equals to positive 3. And don't forget, it's mx plus b. So there it is, 3x minus 5. And the restriction, it start at 3 onward, not including, like right there, x value, 3 right here. So it's going to be, it's basically related here, by the way. They're all connected. So it'll be 3 not including and greater. Done. I'm pretty sure. As long as my 5 is right. The minus 5, I mean, I think it's right. You can kind of go over the graph. Mine's a little pixelated, but I think it's good. Yeah, 1 over 3 down 3. Yeah, okay, that's it. What do you think? Should we look at the next thing?
Can we try 71 and 72? It's above those.
Okay. That's one graph.
Or just one of them. I don't know, whichever one.
Okay.
We can get done.
Let me see the graph of each radio segment. If you don't, yeah. Grab radio segment. Oh, yeah. Yeah. It's basically the same thing as you did the piecewise, but you only do one part, one piece. But it tells you start there, you know, like start between there and start there. But let me show it to you. Let me grab this. So all you do is solve for y, the easiest way. Now, that's not always true. Let me see if it's the word sketch. No, it's literally want you to graph. Had this been even numbers divisible by, 12 divided by these ones, then you've been able to do it fast. But you can still do it. For example, let's do it this way. The fastest way is to get the intercepts. Do the intercept way. Let's do it again. This is the best way, okay? But you put a coordinate in the graph. Your teacher will have to accept it. Here, let me show it to you. So if you x-intercept, all you need is x and y-intercept and connect them, and you get a line out of it. That as simple as that. But let me see. If not, you know what? I take it back because, all right, let's do y-mx plus b. So we're going to do y-mx plus b coming out of this right here. So we're going to do y equals mx plus b. I think it's the most understandable way. The intercept, it's not bad, but I think it will get confusing because of this right here. But watch, when you do it this way, I think, yeah, it goes together. The y-mx plus b goes together with the piecewise. You only do one piece. Wait, let's solve for it. Let me see. I'm going to skip a step. I'm not copying this again. So I'm going to subtract both sides by 5x and put it in front of 12. See, you okay with that? Subtract both sides by 5x. And then divide both sides, all of it, by negative 2. So you're left with y equals positive 5 halves x plus 6. Then we're going to graph that. Is that okay? Yeah, I think this is the best way because you can actually do a rise and run. So here we go. We go up 6 right here. I will check if that's 6. Yeah, it looks 6. And then you're going to rise 5, run 2. But that means you're going to go backward this way too. But let me do the rise 5, run 2 first. Rise 5, run 2. From that point, this is your 6. Your b equals 6. You may have to help me erase that in a second. Double check. 6. Yeah. Rise 5. Yeah. And run over 2. That means you're going to do down 5 and run over 2. Down 5. I'm not going to sketch it. Down 5. Or I'll do 2 this way first. 2. And then run. And then down 5. So here's another point. Then you connect them. Now, you're going to have to do it carefully. you're going to do it the way that it's kind of like inclusive of that. So it's greater than. That means you don't need this side at all. All you need to do is this. The graph, final graph looks like this. Exactly this way. And then open this dot. See, open this dot. So here's the final graph at 6, okay? Here's the graph, just like that. You can erase this thing here if you want. But show, you don't need to erase it, just show what you did. Your trace of rise and run. Like that. So here's the graph. You see it? How I got that? I made this into ymx plus b. It's just like the piecewise of this one, but you only do one part. That's it.